In this video, we're going to graph a sine and cosine function. We're going to combine different transformations we've talked about, and we're going just to basically use this knowledge to graph a transformed function. All right, so let's start with the transformed function. Y equals sine, or 2 sine, of x over 2 plus 3. So let's break this apart. First things first, this first value right here is my amplitude. That's a P, not a B, amplitude. This right here is actually my period, and I'll show you how that works. And this one right here, that color is really close to the color that I just used. This one right here is going to be my midline. All right, and so let me show you how I break this apart to make this my period. Because remember that I could reverse the operations that were conducted on this to produce x over 2. It's a very easy pull apart. It's a very easy expansion. Because it's just 1/2 times x to make that x over 2. All right, and remember, if you're multiplying 2x, then that's going to be your period, a period change. So my amplitude, and I'm just going to write this out, is equal to 2. Sorry, my eyes were looking at the 3. My period is going to equal 2 pi over 1/2, or 4 pi. And my midline is going to equal 3. All right, so I've taken some liberties. I drew out the function here. Let me see if I could move it over. And here's the parent function. And again, we have a period of 2 pi. So this is the parent function. This is y equals sine of x. We are now looking at an amplitude of 2, but a midline of 3, and a period of 4 pi. So I'm going to start with the period first. Period, I made this coral color. It's kind of close to that one, so I'm going to actually change it to this lighter pink. Yeah. And the period now is 4 pi, which means this extends all the way out to 4 pi. Grab this guy right here. Let me extend this out. That's a slightly different color, but we're going to go to 4 pi. Half of 4 pi is 2 pi. So 4 pi, we begin here at 1. I'm not going to add the amplitude in here yet, but I know halfway between these 2 points, halfway between 0 and 2 pi, we're going to have my maximum. And halfway between 2 pi and 4 pi, which is 3 pi, we're going to have my minimum. So my period has stretched my graph out. Okay, now the next thing I'm going to do, I think I'm going to do the amplitude. So the amplitude is 3. I keep saying 3, it's 2. I want to change that midline to 3 already. So we're going to put 2 about here and -2 here. So every one of these now light pink dots, I'm going to multiply by 2. So again, 0 times 2, well, that's 0. 1 times 2, well, that's 2. 0 times 2, well, that's 0. -1 times 2, that's -2. And 0 times 2 is 2. up, down, down some more, and then up. Nice squiggly lines, Abney. They're beautiful. Now the last thing I'm going to do is I'm going to do the midline, which basically means I'm going to move each one of these blue points up by 3. So I'm going to do 0 plus 3, which is 1, 2, 3. 2 plus 3, which is 5, 1, 2, 3, 4, 5. So we're going to move it like up here to 5. And then I'm going to do 0, add 3, so we're going to be here at 3. Negative 2 plus 3 is 1. And 0 plus 3 is 3. So what should really happen is that this previous lineup of those 3 dots from beginning to end of my period now move up to 3. So now we have this move up of this midline to 3. There it is right there, to 3. And that means the full function is now kind of moved up. And we'd see a lot of these midline shifts from the idea of a Ferris wheel, because you're not going to go underground when you're riding a Ferris wheel. You will be off the ground at some level. So here is what this would look like. And you'd see again this in a lot of those Ferris wheel type of examples. So here's our transformation of the graph of sine of x to 2 sine of x divided by 2 plus 3. Alright guys, so if you have any questions, always feel free to ask. Enjoy my nice drawings, and I will catch you in the next video.